Hello pre-calculus students, and welcome to the second video in our series here on taking limits. And in this example, we're going to take the limit, this should be a negative 3 here, of x squared plus 7x plus 12 all divided by x squared minus 9. So first we will try substitution. So what if we try putting in negative 3 here, so negative 3 squared plus 7 times negative 3 plus 12 all divided by negative 3 quantity squared minus 9. Well, let's see, you have 9 on the top minus 21 plus 12, all of it over 9 minus 9. And we run into a major problem here because we get 9 minus 21, which is negative 12, so this is 0 divided by 0, and this is undefined. Okay? And so this is a big issue. So substitution does not work. So what we're going to have to do here is try to somehow eliminate the denominator. And I'm going to say that this whole thing is equal to the limit as x approaches negative 3, and we have to write the limit at each single stage in here. And I'm going to factor the top. So this is x plus 3 times x plus 4, okay, divided by, and this is a difference of squares here. So if you don't remember how to do this, look back in some of your work for Algebra 2, or ask a friend or a teacher for help. But this is x plus 3 times x minus 3. And to verify that that works, just a little bit of review here. X plus 3 times x minus 3. Well, x times x is x squared. X times negative 3 is negative 3x. 3 times x is plus 3x. And then 3 times negative 3 is negative 9. The middle terms here cancel, so now you get x squared minus 9. Okay? So that is in fact true. Now, what's really nice about this is you have x plus 3 on the top, x plus 3 on the bottom, and this will cancel. And now that that goes away, we have limit of x minus, as x approaches negative 3, of x plus 4 over x minus 3. Okay. Now we can try direct substitution. Okay, so once we eliminated the denominator, now we can do direct substitution again. Negative 3 plus 4 over negative 3 minus 3. Okay? And it's okay to take this limit away because now we're using direct substitution. I should put the equal sign in here though, because otherwise it's no longer an accurate statement. And this is a fairly simple idea. This is 1 on the top, and then negative 3 minus 3 is negative 6. So negative 1, 6 is our answer here. Okay? So the main idea here is that if you have a scenario where you end up dividing by 0, we try to eliminate that denominator by doing some factoring and just using our algebra skills to get that done. And then we can, after we've eliminated the problematic part here, then we can just make the substitution here and here, and we won't end up with a problem of dividing by 0. So I do want to illustrate why this works and how it works. So let me show you here on my grapher, and we're looking at y3 here. I know I got some other stuff going on in the other part. So this is x squared plus 7x plus 12 divided by x squared minus 9. So when I graph this, you'd think it would be a quadratic, but it turns out it's not. Okay, so let's see what happens when we plug in negative 3. Trace negative 3. And you can see here that it is undefined. Now, for those of you who remember these types of problems from earlier on in the year, this is a hole. There's a hole there. So the value here is undefined. However, if we use our table And I'm going to plug in numbers that are very close to negative 3, so negative 2.9. And you see that's this value. We get it even closer, negative 2.999. And we get to this number. Okay. And then negative 2.99999. We get this number. Okay, so this is 0.16 repeating. And we'll get even closer, 2.9999999. And this is 1.6 repeating. Okay. We can also go in the other extreme, negative 3.01, negative 3.000001, okay, and it also approaches a similar value. And it turns out that negative 1/6 is in fact a negative 1.6 repeating. Okay. So the main idea to get out of this whole exercise here is that the exact value at negative 3 does not exist. Okay. The exact value is undefined, but the limit as the function gets closer and closer to that point does exist, and it is equal to negative 6. And this is kind of the major challenge, and the beauty of calculus is that we have to do these problems where we could end up with undefined values, but using the concept of a limit, we can still get the exact value without actually having to make the substitution in there. So try a few more of these problems on your own. Thank you for watching, and have a wonderful day.